Derex, the world's best-selling industrial drill sharpener. The XT3000 features a patented design that sharpens drills accurately in less than a minute. The super abrasive replaceable sharpening wheel can sharpen over 6,000 drills. It sharpens standard twist drills from 3 mm to 21 mm and offers quick point angle changes, creating angles from 118 to 150 degrees. And accessories are available to sharpen larger and more specialized drills. The large drill attachment will allow the XT3000 to sharpen drills from 13/16 of an inch to 1 3/16. The 90 to 120 degree attachment allows you to sharpen spotting drills. Left-handed chucks are available to sharpen left-handed drills from 1/8 inch to 13/16 inch. The XY table attachment is necessary to use the countersink, brad point, and step drill attachments. The countersink attachment will allow you to quickly and easily sharpen countersinks. It attaches directly onto the XY table. The brad point attachment sharpens drills from 1/8 inch to 31/64 inch. An optional larger chuck can sharpen drills up to 13/16 inch. The step drill attachment makes it easy to align and sharpen step drills from 1/8 inch to 31/64 inch. An optional larger chuck can sharpen drills up to 13/16. Your model XT3000 is capable of turning regular drills into self-centering, fast-cutting, high-performance drills. Your Derex has an innovative design that creates the right geometry in all of these areas. It starts with patented dual cams that move the drill in 2 directions, in and out, up and down, creating exactly the same motion factories use to make new drills. And your Derex uses an industrial-strength super abrasive electroplated sharpening wheel so that thousands of drills can be sharpened without the wheel wearing down or changing shape. At Derex, we want to ensure that you are fully satisfied with your product. Consult your user's guide and our website for additional information and contact numbers. Congratulations on your purchase of Derex, the world's best-selling industrial drill sharpener. The V390 features a patented design that sharpens drills accurately in less than a minute. The super abrasive sharpening wheel can sharpen up to approximately 2,000 drills. The V390 is designed to sharpen high-speed steel, carbide, cobalt, and parabolic drills, as well as TIN and other coated drills. It sharpens standard twist drills from 1/8 inch to 3/4 inch and offers quick point angle changes, creating angles from 118 to 140 degrees. Your model V390 is one of the lowest priced industrial grade sharpeners on the market and is capable of turning regular drills into self-centering, fast-cutting, high-performance drills. Drill geometry. Several key drill terms will be referred to throughout the video. The point angle, the cutting lips, the web, the chisel edge angle, and the flutes. The term relief refers to the way the bit falls away behind the cutting lips to prevent the heel from rubbing. Your Derex has an innovative design that creates the right geometry in all of these areas. It starts with patented dual cams that move the drill in 2 directions, in and out, up and down, creating exactly the same motion factories use to make new drills. And your Derex uses an industrial-strength super abrasive electric-plated sharpening wheel so that thousands of drills can be sharpened without the wheel wearing down or changing shape. Split point drills. Your Derex can split the point of any drill. The main advantages to a split point drill are reducing thrust and eliminating walking at the drill point. These are most important when the drill is used in a portable drill or in drilling applications where bushings cannot be used. The split point also has 2 positive rake cutting edges extending to the center of the drill. This helps produce smaller chips that clear easily out of the hole. The drill digs into material faster and reduces the drill's tendency to walk, so you rarely need a pilot hole. To create a split point, a secondary surface is ground from the heel to the tip of the drill. This narrows the web and creates the second set of cutting lips at the tip of the drill. Split point drills can be particularly useful when drilling in metal. Drills made from specialty materials like cobalt and carbide have thick webs and work best with a split point. Point and lip relief angles. On your Derex, you have the option to adjust the point angle and the lip relief angle on the drill. Many drills have a steeper 118-degree point angle. This angle is good for soft and low-strength materials, such as some cast irons, aluminum, plastic, and wood. Decreasing the point angle increases the length of the lips and decreases the feed pressure. A shallower 135-degree point angle is often preferred for hard and tough materials, such as high alloy steels. Increasing the point angle reduces the length of the lips and increases the feed pressure. Depending on the material you are drilling in, you may choose to increase or decrease this angle. You can also adjust the lip relief angle. This is the angle at which the surface of a drill falls away from the cutting edge. To prevent rubbing, the cutting edge must be relieved to permit the chisel edge to penetrate the workpiece. Consult your user guide to learn more about angle adjustments. Stay tuned. The following CD includes a tour of your Derex, a sharpening overview, detailed demonstrations for precision sharpening, and cleaning and maintenance instructions for peak performance. A tour of Derex. The key parts to the Derex are the chuck, the alignment port, the sharpening port, and the splitting port. This is the chuck, the alignment notch that helps position the chuck jaws that hold the drill, the chuck knob that tightens the jaws, the split port notch for split alignment, and the chuck cams that generate the drill geometry. Now look at the alignment port. This is the material removal selector knob. This is the relief adjustment settings and alignment paddle. When pushed in, the paddle opens the pawl arms. This is the drill stop. And this is the alignment locating pin. It is used to guide and hold the position of the chuck. This is the sharpening port. These are the cam guides that create the sharpening motion. And this is the point angle selector. This is the splitting port. This tab guides the chuck during the splitting. This is your split angle adjustment indicator. And this is the split depth adjustment knob to control the depth of the split. Here is the cover you remove to replace the sharpening wheel. This is the vacuum port. This is the plug, and this is the on-off switch. And this is a set of quick-step setup instructions. Detailed demonstrations. Remember that 4 key areas can be sharpened: the primary cutting edge and the secondary clearance angle of each flute, the primary cutting edge and the secondary clearance angle on the end. Before sharpening, insert into the air spindle the correct 5/seat collet for your end mill shank diameter. Place the end mill in the collet just before the beginning of the flutes, and set the locking dog. Tighten using the draw tube. Also, ensure that the motor direction is correct. The wheel should turn clockwise to sharpen high-speed steel and cobalt end mills. It should turn counterclockwise to sharpen carbide end mills. Step 1. Set the stylus. As you pull the spindle, the stylus guides the cutting edge following the contour of the flute. With the stylus in the primary position, loosen the size adjustment knob and slide the stylus in or out until it is set in the center of the end mill flute. Each time a new end mill is sharpened, you will position the stylus according to the end mill diameter. Verify the stylus is positioned correctly before sharpening. Do a practice run. When the stylus is set in both the primary and secondary positions, the end mill should flow smoothly over the stylus. If the end mill drags as you pull, you will need to reposition the stylus. Step 2. Sharpen the flutes. Now you are ready to sharpen the primary edges of the flutes. You sharpen the flutes from the shank to the end. Thread the end mill onto the stylus until the shank is as close to the stylus as possible. Turn on the motor and advance the feed knob until the wheel lightly touches the end mill. Then advance 1 to 2 graduations more. Note that each increment of the feed knob represents 2 1/1000ths of an inch in movement. Sharpen by slowly pulling the end mill away from the wheel until it comes off the stylus. Push the clearance handle down and thread the next flute on the stylus. Slowly release the clearance handle and again pull the end mill until it comes off the stylus. Repeat this process for each flute. Now, sharpen the secondary clearance angle. You do not always need to sharpen the secondary geometry. The primary cutting edge should be 1/4 the width of the entire land. Only sharpen the secondary when the primary cutting edge is too wide, more than 1/2 the width of the land. Move the stylus into the secondary position by loosening the knob and rocking the fixture up and back as far as possible. Sharpen the secondary as you did the primary cutting edge. Thread the end mill onto the stylus as close to the shank as possible. Move the feed knob into the secondary until it touches. Then pull until the end mill comes off the stylus. Then push down the clearance handle, reposition, release the handle, and repeat until the secondary clearance angle on all flutes have been sharpened. Step 3. Sharpen the ends. The outer edge of the grinding wheel is the only part of the wheel that is used to sharpen. It is critical that this edge be sharp. See your user manual to learn about dressing the wheel. When sharpening the ends, set the index collar for the number of flutes on your end mill. With the motor off, move the stylus pin out of the path of the wheel. Loosen the index collar, slide forward on the spindle, and rotate until the index pin drops in one of the holes marked with the appropriate number of flutes. For example, 2, if your end mill has 2 flutes. Now, move the spindle forward, leaving the pin engaged, so that the outside corner of the wheel can grind the end of the end mill. Turn the spindle to position the cutting edge so that they are horizontal. To secure this position, tighten the locking knob on the indexing collar. Turn on the motor, and, using both the feed and cross-feed knobs, move the wheel toward the end mill until it lightly touches the end. Sharpen the primary angle by using the feed knob to feed the wheel across the end mill with a slow, even motion until the edge of the wheel reaches the center. Reverse the feed knob to move the wheel to the outer edge. Pull up the index pin and rotate the spindle to the next hole marked with the appropriate number of flutes and sharpen that flute end. Sharpen as before and repeat until all flutes have been sharpened. Sharpen the secondary clearance angle only when the primary cutting edge has become too wide. Loosen the spindle knob and move the spindle lever to the right so the spindle is in its lowest position. Sharpen the secondary clearance angles on the end with the same procedure used to sharpen the primary cutting edges. Relief angles on flutes. Changing the relief angles on the flutes is simple. Instead of aligning the stylus in the middle of the outside edge of the wheel, use the cross-feed knob to move the wheel edge. The further to the left you go, the more relief you will get. Move the wheel to the right to reduce the relief. Maintenance and cleaning. Your Derax is a precision tool and should be cleaned regularly to remove dust and grit. Accumulated dust and grit affect the accuracy and effectiveness of your sharpened end mills, and grit can wear and plug the air spindle sleeve. When you clean, use a lint-free cloth to clean the outside of the air spindle. Alcohol can be used to clean the inside of the air spindle. Cleaning the collets with compressed air will ensure the collets are centered in the air spindle. In addition to dust and grit, you will need to periodically dress your grinding wheel. See your manual for more information. At Derax, we want to ensure that you are fully satisfied with your product. Consult your user's guide and our website for additional information and contact numbers. Thank you for buying Derax.
This is the Sterling DM43 sharpening system. Out of the box, it has several component parts. The base unit, a protractor table for sharpening inserts with gun drill regrind plate with preset slots for grinding the different gun drill angles, tool holder, diamond wheel, and tools, nuts and screws to assemble the unit. On the bottom of the unit, for assembly, they will remove one of the stops, plates, slide it on the table onto the surface, and install the stop screws. Okay. With the table installed, we're not going to be sharpening inserts, so we're going to install the gun drill table. There is a pin that locates on the table and a little screw or nut built into the table which will be attached. The table is positioned so a pointer in the table points on 0. At that point, you install the screw, tighten the screw down in the center with the table positioned on 0 degrees. Back part of the machine is tipped up. Install the wheel so the pin locates where it should, and secure the wheel with the other screw. Now the machine is ready to be used. There is a preset angles for the grinding angles of the drill. There is a vertical adjustment and a scale on the side of the unit that gives the degrees. The machine turns the wheel in 2 directions, clockwise, and the wheel has to stop before you turn it in reverse. So there's 2 different directions. We'll use a gun drill. In this case, we'll put the gun drill in the tool holder so that the tip is clear of the tool holder, and tighten it in position. There's a chart for regrinding gun drills. There's 5 main grinds and there's a handed chamfer at the end. Using this in a cookbook manner, we'll start by sharpening what's called the primary relief, the first shown here, which is the outer angle of the gun drill, very small. The typical rotation of the wheel is opposite what you'd normally expect, in this case clockwise, when the drill is in the 30-degree position. You grind to remove wear on the drill, stop the wheel, reverse the wheel, and go into the inner relief that was shown in the dark color here, which also establishes the D/4 point position. In this case, you're working on the opposite side of the wheel, so with the rotation again going, in this case, counterclockwise. Pushing the wheel, the drill tip against the wheel, You grind to establish a D over 4-point position. So now, this can be measured on a comparator or some measuring device, or with a reasonable amount of skill, you can do it by eye. So this is the main resharpening of a gun drill. Steps 1, step 2 now have completed. So you have now the drill will cut. The rest of the grinds are clearance grinds. So step 3 is the secondary relief, where we put a clearance grind under the cutting edge. The wheel is stopped, rotated back in the original direction. Vertical elevation is moved down to 20 degrees. The drill goes back into the 30-degree slot. This is a very quick grind. Step 4 is called the front clearance. The triangle at the bottom clearance angle. For this angle is 25 degrees, which is all the way down, and you use the 0-degree slot on the table. You grind to create a triangle on the back side of the drill until it comes up to the back edge of the primary relief. The last grind is called the oil clearance, most often commonly called a dub-off grind, where the wheel remains down. You use the 20-degree right-hand slot, and you actually grind off. You go to this right-hand slot and grind the dub off. You grind the dub off until the V you're grinding goes back to the bottom of the V of the tip. So this is the completed grind, 4 and 5 facet grind. The only thing remaining is what's called a periphery chamfering. Turn the machine on end, so the wheel's vertical, and you'll rotate a hand chamfer around the perimeter of the drill that blends the ground angles to the side of the drill. Now the drill is completely finished. Alyans.